Good afternoon, and a very warm welcome to everybody on this National Particle Therapy Symposium, presented by ourselves, the Peter MacCallum Cancer Centre here in Melbourne. My name is Gerry Hanna, Director of Radiation Oncology, Peter Mac, and I'm going to be one of your many session chairs throughout this two-day symposium. I want to thank you all for joining. We've over 100 people online and 209 participants registered for this conference, and we're delighted at those numbers. That's in spite of all the challenges, and in spite of those challenges, we've managed to develop a new way to approach this and other important symposiums, creating an online space to present, share, and connect with one another on important radiation oncology topics. And we really do thank you for your attendance today. As we start this conference and symposium, we'd like to start by acknowledging the traditional owners of the land on which all of us are joining from, and we honour their elders, past, present, and emerging, and those present with us today. As for us, we acknowledge that Peter MacCallum is on the lands of the Eunji people, who have been custodians of this land for thousands of years. Now, as we start, I would very like to welcome Kathryn Whitfield from the Victorian Government Department of Health and Human Services. And I'd like to hand over to Kathryn to add her welcome on behalf of the department. Kathryn, thank you very much.
Thank you, Gerry, and good afternoon, everyone. I'd like to join with Gerry in welcoming you all to this virtual 2020 National Particle Therapy Symposium being hosted by Peter MacCallum Cancer Centre. I'm certain that you will enjoy the virtual program which has been put together with a range of interesting presentations and opportunities to discuss related issues. I thank the organising committee for their hard work in convening this symposium and rising to the challenges that Gerry outlined, and for their kind invitation to me to help open it, which is my very great pleasure. I think it is great that we now have some certainty about the delivery of the South Australian proton beam therapy service, slated to be open from 2024. This will be a very significant step forward for cancer care in Australia that we will all be looking forward to. However, based on observations of overseas jurisdictions, we know that the South Australian facility will not have the capacity to meet all of the emerging demand for this treatment option for the Australian population. We know that a number of jurisdictions, including I think the Australian government, recognise this. And I think that means it is just a matter of where and when and perhaps how many. Of course, the joker in the pack here is what none of us could have predicted, and that is the COVID-19 pandemic and its economic and global disruption. It remains to be seen if that supports or limits further investment in proton therapy in the short term. Recognising that there will be a demand gap with only one Australian proton therapy facility, the Victorian Government has supported the development of a robust proton therapy business case for the development of a facility here in Melbourne. Whilst the budget processes to date have not delivered the required full investment for the development, the business case remains open, able to be updated should circumstances dictate. Of course, building a proton therapy facility is just part of the story. It will need to sit within a system at both the state and national level. The clinical community, i.e. all of you here, and the health system will need to be prepared to ensure those patients with the most potential to benefit from this technology are referred, triaged, and treated in a timely and equitable way. In Victoria, we have already or are establishing a number of building blocks which we think will support our ability to deliver or to participate in a national proton therapy service. We have long established statewide referral pathways for paediatric radiation oncology services, including an existing Tasmanian pathway. We are currently developing statewide referral criteria, pathways and systems for our new MRI LINAC and gamma knife services, which are due to start treating patients in 2021. Noting that these new services represent the Victorian Government's ongoing commitment and investment in new radiation oncology technologies for the state, and that both will be designated statewide services. As noted above, Victoria has developed a robust business case for proton therapy, and as part of that process, we have worked on determining relevant clinical indications and utilisation rates for our population. We've committed to and undertaken scoping work on establishing a proton therapy clinical registry, and we've also recognised the need for upskilling the workforce and have subsequently invested in training for Peter MacCallum radiation therapists and medical physicists in proton therapy treatment planning. And we have done all this because we are cognizant of the need for systems and the need to build expertise to not only support a local proton therapy centre should it arise, but more immediately, we see this investment in training and systems will support informed, transparent, equitable referral pathways, and by building local expertise, will ensure appropriate proton therapy triage of Victorian patients with the greatest potential for clinical benefit, and therefore improve overall outcomes. Both of these strategies will support referral of Victorian cancer patients to proton therapy wherever the services are located. Currently, that is overseas through the MTOP program, but as indicated, from 2024, that will be to South Australia, at least in the first instance. And that will be a good thing, as the COVID-19 pandemic has shown, access for Australian patients to overseas proton therapy can be disrupted, and national self-sufficiency will be important going forward. COVID-19 has also highlighted the need for not only a proton therapy facility in Australia due to international border closures, but also arguably it has underscored the need for a distributed national system of proton therapy, given our recent experience of local state border restrictions, which is not something we would ever have contemplated pre-2020. I guess what I'm suggesting to you is that we collectively need to be planning and establishing the systems, processes and networks that will support the introduction and potential diffusion of this technology for the benefit of our patients. Events such as this symposium provide a forum to engage with these issues. And if you like, that's your challenge or your homework for the symposium. In Victoria, we are excited by the range of new technologies becoming available and what that will mean for our cancer patients. Clearly, the addition of Australian access to proton therapy, combined with new statewide services including Gamma Knife and MRI Linac, will allow our patients to be offered the very best treatment option for their clinical indication in their own country and potentially into the future without having to leave their own state, delivering true personalised medicine and radiation oncology, an exciting prospect and ambition for the future. So I will leave it there, and again, thank you for your participation in this symposium, and I hope that you will enjoy and be stimulated by your discussions. Thank you.
Thank you, Kathryn, and thank you for joining us and taking some time out from what is a very busy schedule, certainly over the last number of months. Now, a little bit of housekeeping and platform guidance with this new virtual system. I want to go through a few little details, if that's okay with everybody. And first to say is that you'll find that there will be a reception where you'll find the agenda of the symposium, and you'll be able to work through what's coming up next, that type of thing. Down the left-hand side of your screen, you'll see your virtual locations. The stage is where all the presentations can be viewed. And during the event, when something is live, you will see a red icon on that stage. Underneath this is the sessions. You're welcome to create your own networking rooms there. You will also be able to find people to chat to individually in the people section on the right-hand side. There's also the exhibition function. Please explore this feature as you please to learn a little bit more about some of the pediatric work that we've done at Peter MacCallum and work in that space to date. Also the chat function on the right-hand side. Our event organizers will let you know what's coming up next. We encourage you to use that chat function to ask questions and to connect with one another. More importantly, there will be live question and answer sessions after each presentation with each of the guest speakers. We ask that you post any questions that you would like to be answered in this feature throughout. If at any point you need any help, please search for event support in People and somebody will assist you immediately. And really, without further ado, we're going to move to our very first sessions, which is our State of the Nations updates. Don't forget to put your questions in the chat function, and we will try and get to those as we go through the questions. Now, it's my very great pleasure, as Kathryn from the department had mentioned, we have our first centre coming online, hopefully in 2024 in Adelaide in Southern Australia. And to give us an update on that is Associate Professor Michael Penniment, Senior Radiation College at the Icon Centre in Southern Australia. Just unmute there.
All right. Sorry, and I'm already off to a bad start. I'm now unmuted. I thought Gerry, when he was giving us a little bit of housekeeping, was going to tell us where the toilets were, but this is a very unusual experience. I hope everybody can hear me well, and I'd love to thanks for everybody for inviting me to talk about the Australian Bragg Centre. And as we've said, we're now building. That shot is of the Premier and the Health Minister and some others a few months ago now breaking ground. And indeed, in terms of ground, we're on the land of the Kaurna people in Adelaide, and we're very respectful of our elders, past and present. And this is, I think, an enhancement of their wonderful land to build this fantastic centre. And now, here we go. Yes, now that's the team in terms of, for the small team that just shows, this again was a few weeks ago, the start of the build. Already there's been a bit more concrete and the build is going up as we speak. As myself on the left, Peter Graysky and Hien Lee. We're adding to the team Scott Penfold, our head of physics. What I should have done was Scott Penfold's wife had a baby today, so in fact we could add another person to the team, and congratulations to Scott. But growing the team, I think, is the theme that I want to sort of concentrate on, because I think already, as Gerry and Kathryn mentioned, we're building a national centre, and we have a team in Adelaide, but I mentioned in the particle therapy symposium this morning how we can really start to grow the national team. Our core unit in Adelaide is essentially 4 consultant radiation oncologists and our full-time Bragg fellow, 4 dedicated radiation therapists, 6 physicists, an RT PhD candidate, and the University of SA has a team in terms of research and a research nurse in our centre. Now, the thing about that group is over a number of years, they have developed a core competency in proton therapy. Recently, last weekend, a number of us were at the Penn Roberts Centre course in the USA. Again, we were in it from places such as my backyard. And the Christie course also participated, but about half that team has actually worked in proton therapy units around the world. And the next phase for our development is to continue local training through the universities and through our centre, key hires, and also the interstate faculty, which I really want to just throw out there as a concept for us just to think about when we leave at the end of this symposium. In essence, I'm in a position where we're building our unit. And I think that, as I mentioned in the workshop this morning, I'd like to think that core critical staff in each of the states may ideally be appointed to an Australian Bragg Centre faculty as a tangible involvement in the project, and also a clear way that we can harmonise what we do in terms of every aspect of proton therapy. And that builds capacity in terms of staffing and knowledge for when we do roll out other centres. And in regards to some of the activities that we're doing, this is not a complete list, it's just a snapshot, but we're doing, as part of our routine comparative planning work, we have monthly audits of the dosimetry and a discussion of what was developed, and also to follow through MTOP applications in terms of their progress. We've started a monthly proton therapy journal club for the whole of the Bragg team, but there is absolutely no reason why now with the technology we couldn't easily include members from all over Australia in terms of these activities. The PPCR, the North American database that we were invited to join from the Mass General Harvard friends, which has cases in proton and photon cancer, pediatric cancer. We've started that only a fortnight ago, where we've got the final approval to access their database and to put our own cases in, and we've put 3 pediatric cases in the last fortnight. So we're absolutely off and rolling in terms of in that database, and we have some projects that we'll be able to use the North American database we'll be able to prosecute their database and actually come up with some significant proposals that we can use their data to help us publish. Where I suppose in relevance to procurement, where we're involved and have experience in using a number of treatment planning software and other software components that we're getting more and more expertise in. And we also obviously have a significant number of grant proposal and industry collaborations. Again, this morning we touched on areas such as the use of onboard imaging. That's not only onboard CT, but also developing proton therapy imaging as well, and some innovations in couch construction, which already have a number of groups around Australia collaborating in terms of those grant proposals, and we just have to keep growing that. So I've put this slide up before. It's the floor plan. I suppose the biggest thing that we're doing, apart from the previous slide, is obviously building the building and fitting it out. And this is the centre with essentially the 2 gantry rooms and the fixed beam room. I've actually got the arrows around the wrong way, but there's a fixed beam split, so that there's a dedicated beam line for research and a dedicated line for ocular treatment. And I think that's important for us to know. We've also ordered the furniture online. Unfortunately, that was something we got wrong. That is not photoshopped. Anybody that's been to the Broad in Los Angeles would know that's an installation that literally you can relive your childhood by walking under it and thinking your family's having dinner. So the furniture hasn't been ordered for the Bragg Centre. It will be a little bit smaller. So the build, it has started. We also know that it's going to be a 13-storey building that will now be called the Australian Bragg Centre, the whole building, which I think is fantastic for our profession. I think it's also great that the plan is for the Bragg Comprehensive Cancer Centre to open in 2023, when the building will be completed. That will also be when the synchrotron is installed and we begin commissioning. At the same time, or in fact very soon, we should have final approval for Proton, the builders of the synchrotron, to start a assembly and testing facility, which will be built off-site, just very close to the CBD. But that'll be a fantastic opportunity for higher level research certainly in physics, but also software development and a number of other aspects. And I think that'll be also the facility that Proton will use in terms of synchrotron development for the whole Asia Pacific. So final approval is coming. So it's not quite done and dusted, but it looks very good. Also accommodation. As we all know, there's so many moving parts in this. We're developing, we're pleased over the next 2 years that we have a very comprehensive plan, and something as simple as accommodation. It's now been announced that the Cancer Council is building a new facility with over 160 beds. We're starting discussions in terms of specific family accommodation, paediatrics and capacity, but that'll be a great extra factor. And the final slide, which is really just to sort of stir a little bit, but also just to throw up some points that we can discuss. I mean, clearly there are some things that we need to collectively work on. Obviously, the recurrent funding model, so that we can get patients easily to the Bragg Centre. The MSAC proposal has gone in. we will wait decisions on that. As I say, really very interested for us to feedback to me in terms of how do you want me to push the development of a brag faculty. I would really like to see the people that are at this symposium having a clear avenue to have a connection to the brag, so that there really is a group in Sydney, Melbourne, Brisbane, Tasmania, where all over Australia, that there's an expertise that patients can look to that those brag associates. That will also drive the timing of the expansion of the MDTs. Clearly, I think from the college and other strategy and TROG, we've talked about expanding the MDTs to have very specific paediatric skull base and other MDTs that will look at proton therapies usage. Similarly, the role of the college, I think, is absolutely crucial and front and centre in terms of training and a number of things. There's been a little bit of discussion. It'll come up, I think, through the afternoon in terms of engaging with actually driving things like the patient information sheets. I see the college, and I'm just putting it out there, I see the college as supporting their fellows, as being a clear repository of advice and training, but maybe something that's as quick and as easy and as immediately relevant in terms of some information that doesn't need significant scrutiny from a board point of view, but just needs to be got to the consumer quickly. That might be something that resides in another forum. We know at the far end of the spectrum, social media is a good way to get quick information out there. At the other end of the spectrum, journals and publications will take a couple of years to put that into the ether. And in between, there's obviously ways, and even if it's adjuncts to the college, such as targeting cancer, how do we get something that will be useful to consumers that's been written today and get it to them tomorrow? And I'll be really keen to hear our consumers that I know are online discussing the role there. And the role of flexible associations and ways that we can connect. Similarly, the other thing that we discussed this morning, which I had done my slide before this morning, but it fits beautifully, is the clarification and unification of comparative planning for MTOP. I mentioned in the last symposium that I really see comparative planning and the things that we're doing at workshops such as this morning as really important for two completely separate areas. One is training, getting a number more of staff much more au fait with proton therapy and what it can do, but also the issues that are critical to avoid and to be aware of. And on the other hand, to drive a very consensus view in terms of putting up excellent proposals for MTOP funding. We've had a couple of cases in the last month even where centres that I don't think are represented in today's discussion, so they're not core proton interested centres, that have put up proposals where completely reasonable clinical decisions were made, but maybe not driven in terms of the plan for what will ultimately get an MTOP proposal. So they might look at something like, they may prioritise the integral dose over the dose to cord and pituitary and growing bone. And I think harmonising and having our group really address what are the key reasons why we're doing the comparative planning and running training and teaching, and also running a very clear narrative of how do we get this patient approved for proton therapy funding. And whether or not, I think as the brag is now in the sort of home straight to actually treating people, I certainly, and we're building our team, I think that I'm more than happy that the brag team should be the final point of unification. And I'd like to think the brag team today is here in Adelaide, but maybe in the next couple of months is a broader unit than that. I think that's really the take-home message from the talk, is that we're really rolling, we're on time, we've got the time to address all these things, but we have to get our act together quite quickly. Thanks very much.
Brilliant, Michael. Thank you for that fantastic update. It's really great to see that taking shape in Adelaide, and it's a great, and thank you for reaching out to say, if to build a collegiate approach to delivering protons in Australia, which we've done successfully through the college particle therapy working group too as well. We now move from Adelaide up to Sydney, and Associate Professor Verity Ahern, Director at the Westmead Cancer Centre, is now going to give us an update on the New South Wales particle therapy proposition. Verity, over to you.
Thank you very much, Gerry. I'm honoured to have the opportunity to update where we're at in the Sydney, specifically Westmead precinct venture. So we're proposing a national particle treatment and research centre, and its point of difference is that we aim to provide both carbon and potentially in the future other ions, as well as proton therapy. So a steering committee was convened back at about this time in 2014, and the committee is to provide strategic direction, expertise and governance to inform and oversees the development of a business case. So our membership is broad, including the Sydney Children's Hospital Network, ANSTO, universities including particularly Sydney and Wollongong, Cancer Institute, representation from Trans-Tasman Radiation Oncology Group, and clinicians from the Bragg Centre and Metro North as well. So from the beginning, our approach has been to be part of a network, and really we want to have a world-class treatment facility, but be collaborating nationally in research, clinical protocols, so that together we can be competitive internationally as well. And we do propose to involve centres where there will never be proton facilities, recognising we're a small population and there's expertise in all of our facilities around Australia and indeed New Zealand. So this is a sketch of how we see ourselves in the future, that we are all one collaboration, we are all one team to bring particle therapy to Australia. There are going to be multiple radiotherapy facilities that exist right now, but at a local level they'll feed into, for example, a state-based proton facility, and ultimately I expect there will be several of them because of our geographically dispersed population. But really there's a place for one carbon and potentially other ion facility nationally, and we do need to work together from a referral of patient point of view and agree indications for patients that we will accept into our facilities. And we do need to be treating patients according to agreed protocols. And I think we're making enormous progress with that through 3 proton workshops that we've held this year. The collaboration is really strengthening nationally in a very, very positive way. The New South Wales Westmead precinct vision remains to have carbon ion therapy. We're totally committed to that, and we see this as having clinical advantages to cancer patients, but also enormous research benefits. So bringing carbon and other ion therapy to Australia means that nationally, or internationally I should say, we'll be early adopters. There are only 13 operating facilities around the world now. So that would be brilliant for Australians to be part of that development. We think that as experience around the world grows in proton therapy and the evidence continues to build, it will become clear that there are still some patients who are not managed best. Their cancers still recur despite proton therapy. And there will be a small group, particularly those with very radiation resistant tumours or tumours that are extremely close to critical structures, who may benefit from carbon ion therapy, and we'll understand who they are as we develop experience in proton therapy. So ultimately I expect that referrals to the carbon ion facility will come from the network that's developed amongst the proton facilities in the longer term. So research from the carbon ion facility, obviously enormous opportunities in understanding cancer biology and translating learnings to treatments and selecting patients based on the biology of their unique and individual tumours to either get conventional radiation or proton therapy or carbon ion therapy. So enormous areas of research that will benefit patient outcomes. But from that carbon ion facility, a whole raft of much broader research opportunities that are not directly patient related. and using engineering and experimental physics to really build Australia's profile in science and technology. And I've just given a few examples of where we see a carbon ion facility could fit in a research spectrum. So as Michael has explained, training of our team is what we're doing locally. We have a core group of radiation therapists, physicists, and oncologists, starting with our pediatric team, but now set to expand amongst the different tumour groups slowly and methodically. But we're active in proton planning, and it's a very exciting journey, and great that we're actually part of the national effort to build skills in Australia. So I think our big achievement since the last symposium is that we've refreshed our business case, and in August this year submitted it back to New South Wales Government. It may seem an odd thing to do in a pandemic when we know government funding is very constrained, but actually I think the pandemic has highlighted that we do need the opportunity to offer this treatment to patients in Australia without them travelling overseas in the future. And this is an opportunity to invest in people in Australia from a health perspective, but a far broader science and research perspective as well. And we hope to have a large Westmead precinct facility that seamlessly integrates a health facility with a greater science community, and that will invest in western part of Sydney, which is often seen as an under-resourced part of our state. So we're very excited and not at all put off by the fact that pandemic seems to be causing cost problems. Thank you.
Thank you, Verity. That's a really excellent update, and it's good to see the business case renewed and resubmitted. That's fantastic. Now we're hoping to go up to Queensland to Professor Liz Kenny. And Liz, hopefully you're there.
Yes, I'm here, thanks.
Let's see. There you are, Liz. And Liz is going to give us an update from the Queensland proton therapy bid. Liz.
Oh, thanks so very much, Gerry. So we have always maintained an extremely high level of support for a national, really a binational collaboration, and we emphasised that before actually starting to talk about anything from a Queensland point of view. Queensland has a new government, new minister, and like everyone else, we're budget constrained. So we are refreshing our business case, and this business case, which was very favourably regarded in government, however, will actually be part now of a Queensland Comprehensive Cancer Centre. So that's a very large build with a very large number of zeros after it, housing everything cancer. And so that's where we're at. So there's not much to actually report on in terms of anything tangible, but increasingly, and I think this is a responsibility on all of us, the focus for the country, backed by pharma, has always been on drugs. My service leads the charge there as one of the probably the 2 CAR-T manufacturing sites in the country. And so again and again, I think that, and this is part of the serious collaboration with the support for a carbon facility, serious support, of course, for the Bragg Centre, and fabulous that the cancer centre there is going to be called that. I think that's phenomenal. But really this focus on the need for the best local cure and the best local control long-term with minimal side effects that we can effect. We don't have that voice seriously heard. We don't have pharma behind us to push the case. And so this is part of the responsibility on all of us. It will form part of the serious core of the new business case going in to the Queensland government. We'll be obviously partnering with universities. It's quite likely we will need to partner with private enterprise, whatever that means. to help fund some of the hard dollar infrastructure. So we're still fully committed. This gives us an opportunity, I think. Local cure is always cheaper than systemic therapy. And that's really where we're going to have such a focus in the new upcoming business case. So, Gerry, happy to expand, but I can't give you anything tangible. Thank you.
Thanks, Liz. That's a really excellent update, and I think that's a very powerful comparison where we invest millions of dollars for drugs that extend life, very often by only a couple of months at the end of life. And here is a treatment which, although a large upfront investment, will lead to many, many treatments over decades rather than actually years. So thank you, Liz, for that. Some folks are reporting some little bit of breakup on sound. If you are having difficulty with hearing sound coming through clearly, don't forget to turn off other applications that are connecting to the internet so to allow that to stream a little clearly. I'm just now going to present my presentation, which is from the particle therapy plans for Victoria. And I couldn't help but show this picture of Nigel Anderson treating patients. Nigel, of course, is one of our co-organisers here at Peter Mac. Just when I see Twitter there, just to mention that if folks want the virtual conversation, the hashtag for this meeting is hashtag NPTS 2020, or including also at Peter Mac Radonc. So please use those two forms and we will collate those responses and have that conversation. So I suppose looking back over the last year, what did we get up to in Victoria in 2020? Well, you could nearly put it a blank page in a way, but there's quite a few things happened. If you came into our CBD for up until about the last month or so, you'd have seen tumbleweed rolling down the streets of Melbourne, which is a very unusual sight. Thankfully, now that our COVID case numbers are very much under control, the traffic is back. It now takes an hour and a half to leave our Peter Mac car park. So the mixed blessings of the return of traffic, but it was an exceptionally busy year. And not just in protons. So what happened? Well, first of all, I'd like to say that as Kathryn Whitfield from the department said, there is continued support of both our radiation therapy and physics proton planning positions, where they fund positions inside Peter Mac to undertake comparative planning, to develop our planning acumen and techniques in that way. We still continue dual planning for all the appropriate pediatric patients, and that's in conjunction, not just our planners here, but the planners at the Bragg Centre. And as Michael has mentioned earlier, it is so important to build those links and keep the fantastic links that are in the pediatric space very live and very active. We had Peter Mac participation in the proton planning workshops, 3 this year, the most recent being August, and of course this morning. And I want to thank Adam, Yo, Trog, and all the participants for the hard work and the fantastic presentations and learning and sharing that went on this morning there. We are revising our proton business case, as Kathryn Whitfield outlined. It is still live at the department. It's still under consideration, though not funded in the last round. And to nudge that a little bit, we did write to Minister for Health, Jenny Mikakos, back in June to ask her to reconsider our proton therapy business case as part of rebuilding post-COVID. Now, unfortunately, Minister Mikakos is no longer a minister, and we had to write again to our new Victorian minister, Minister Foley, and that letter has come from the 4 Victorian Public Radiation Oncology directors. We've done this as a joint, not as a Peter Mac thing, but as a Victorian Proton Centre bid in conjunction with the Royal Children's Hospital here in the Parkville precinct. We have no decision back, but obviously that's still under consideration. But as Liz has said, and Verity and Michael, we are in a very constrained financial environment, but we do look forward to the consideration as part of rebuilding our economies post-COVID in that way. Now, where are we due to where's our potential location in Peter Mac? If we look here, this is just looking down on the Parkville precinct. This is the Victorian Comprehensive Cancer Centre, where Peter Mac is located, the Royal Melbourne Hospital, the Royal Women's Hospital, and this is the Royal Children's Hospital precinct. And this location is where we've earmarked the land for the Victorian Proton Therapy Centre. And there's a little bit of greenfield space. We have to, unfortunately, work out how to work the land, but there's quite advanced plans as to how that land space would be measured in that way. But a bit like both Queensland and New South Wales, we have no concrete guarantees as of yet. And very finally, to say thank you very much for your attention for that presentation. So you've heard the updates for the 4 nations, and I hope those are informative. It's really brilliant to see the Bragg Centre taking shape in Adelaide in Southern Australia. What we might do is invite Michael, Liz and Verity back on for questions. And the first question is to Michael, if Michael is there. And Michael, whose approval is needed for the Proton facility? Southern Australia, state or Proton itself? I think that question is probably presumably which government regulation rather than actually which manufacturer.
Yeah, and if I'm understanding the question right, how we sort of achieved the funding was basically our state government put forward $44 million, and we put up a business case to the federal government, which was supported by quite a few. We've done over about 5 years a lot of discussions with a lot of politicians federally, not just South Australia, and I think that led to the federal government contributing the $68 million, which was specifically for the equipment. So I'm not sure if that's the question, but yeah. It would basically needed. I think from a Victorian point of view, the state commitment that you have already and are exploring again is really important, because that's probably what drove the federal government. And I think that the second aspect is that we'd always put up a proposal that we didn't anticipate would meet the long-term capacity needs for Australia. So I think we can sort of start building that narrative that you touched on, I think, Gerry, that Adelaide's a good start.
Brilliant, Mike. Well, thank you. Now, question number 2 is to Verity. Verity, and the question is, when would carbon treatment planning be available to get a feel for the role of carbons in Australia?
That's a great
Verity,
question.
over to you.
If someone's prepared to, I'd love someone to provide us with some funding for a treatment planning system that will allow us to have a play around with that. So we've got the proton planning system, and we're learning a lot. So I think we need to develop our skills locally in proton planning first, and then move forward with carbon ion planning. But how do we know that's what we want and it's got a place in Australia? I think that's really based on international literature. A lot of us are going to international conferences on particle therapy. We have a particular interest on the precinct in radiation biology, radiation sensitivity, hypoxia, and it's a really nice fit for those tumour indications with the sort of research interests that we're developing. I think the other thing that a number of us have done is travel to the carbon ion facilities around the world. There's not many of them, so we've met colleagues over there. We're seeing the sort of cases that they're treating there, and I think it's really that experiential learning that says we want this for Australian patients.
Brilliant, Verity. Thank you very much. And here's a question. What steps are you taking to answer specific family advocacy groups? And I'm going to suggest you do what we're doing that question is park that until tomorrow. Dr. Peter Goreski is going to give us hopefully a fantastic presentation on consumer engagement and patient information and involvement in particle therapy. Now, we're going to move slightly overseas over to Singapore, and it's my really great pleasure to invite Dr. James Lee, based in Singapore, one of our Singaporean college colleagues, to give us an update about proton therapy delivery in Singapore. James, you're very welcome.
Hi. And well, greetings from Singapore, and just want to thank Professor Gerry and Professor Thomas and the team for inviting me here to give a talk this morning on proton beam delivery in Singapore. Well, let me see. Oops. Okay, let me see if I can sit this. Is it okay? The aim of my presentation is really, whoops.
That's okay, James. Just take your time. There's no rush. If you
Want to
share the screen again, yeah, and if you get your slides up, yeah, perfect.
Yeah.
So if you take your time there, as I say.
Yeah. Let me see.
I'll let you work with it. Just as you're working that, James, just to remind folks, we have obviously the Twitter feed, which is hashtag NPTS2020. So please join that conversation as you would like there. And that's just at the bottom of your screens there again.
Right.
Now, James, over to you to share.
Yeah. Okay. Well.
Perfect, James. We can see that. That's perfect.
Right. Good. So the aim of my presentation here is to, well, I can't seem to be able to transit my screen. I'm not so sure. Can you see it? Sorry for the technical difficulties. Okay. So the aim of my presentation now is to provide a brief overview of the development and some of the specs and design thinking of our PBD system in National Cancer Center, Singapore. As you know, the Cancer Center actually started way back in 1968, and now we are going to get a new building in 2022, which means that when we plan for the new building, we're going to have the the proton therapy center that is going to be incorporated into the new building as well. So as you can see here, the new NCCS building will be operational by mid-2022. It's going to be 24 stories, and there'll be 4 basement floors, including radiation oncology. Now you can see that besides radiation oncology, there's also certain public space and as well as other services in the basement. And so it's going to be quite a large facility with many bunkers that's built in. And you can see from the floor area here that we're going to have basement 3 and basement 4 with proton therapy inside, and we're going to have 4 PBD gantries in 1 fixed beam room, synchrotron, and we've got Linux, Brachy, and all the other rooms in basement 3, and in basement 4 itself, we'll have a lot of Linux rooms as well. So everything will be integrated into one facility in basement 3, basement 4, and in basement 2 will be the treatment planning area. And well, since NCC has announced proton therapy in Singapore, 2 other centers in the private sector has actually announced that it will have PBT as well, and they're going to acquire single gantry systems. A bit of timeline about PBT project was way back in 2006 when the then National Research Foundation chairman, Dr. Tony Tan, actually mooted the idea of proton beam therapy when he visited PSI. And then in 2007 to 2010, we actually embarked on evaluating the proton beam technology. And then in 2011 itself, SingHealth Board, and SingHealth is just a public cluster of hospitals of which we are part of it. We are part of the Singapore General Hospital campus. They actually approved our PBT project, and the PERMSEC from the MOH gave in principle agreement to establish a PBT in Singapore. And then we started to prepare our clinical protocols and guidelines for treatment as well. And then in 2012, with all these clinical protocols and guidelines in place, the Director of Medical Services has given the approval to start PBT in NCCS. And then in 2013 itself, we had a request for proposal for PBT system, and towards the end of the year, we shortlisted 3 PBT vendors, Hitachi, IBA, and Varian. And then we also, at the same time, we appointed the architect for the new NCCS building. A summary of the RFP that we've had is actually to look at 4 rotating gantries, 1 fixed beam room, full pencil beam scanning. We wanted it to be future-proof, and we wanted it to be upgradable as best as we can. We wanted to have high uptime, wanted to have long-term partnership with the vendor because this system is going to be around for 10 to maybe 20 years. It must be cost-effective, and we are looking at various RFP committees that is being set up, looking at technical, legal contracts, finance, insurance, building interface maintenance, and so on. And we started our due diligence visits as well. And so in 2014, we did a lot of visitation to Japan and USA, and we did a lot of negotiations. And finally, we arrived at the best and final offer. And we had a Proton tender board, which oversees the whole RFP, and they were they approved the recommendation by our overarching committee to select Hitachi as a preferred vendor. And we also had Varian as a reserve bidder as well. And a letter of intent was also issued to Hitachi at that time. So between 2015 to 2020, we had a lot of discussion with Hitachi on the building interface, with the builders, the architects, and so on and so forth. And towards the end of 2015, we actually awarded the entire contract to Hitachi. And between 2016 to today, they are actually building the new building with the equipment being installed as well. So an overview, you can see that there are 4 gantries and 1 fixed beam right near the end, near where the synchrotron is. A bit about the specs about our Proton system. It's going to be full rotating gantry. It's not a compact system. We decided that we'll go with full rotating gantry. For the accelerator, we have a synchrotron. And for energy change, we've got a multi-energy extraction system, and we have beam matching between the different gantry rooms. There's an age-old discussion always between synchrotron or cyclotron in terms of how we're going to accelerate the protons, and these are just some of the comments. And NCC being no different from any center, we had to decide which type of accelerator we're going to adopt. And for us, we have gone with a synchrotron with Hitachi, and the advantages and disadvantages are actually highlighted here as well. And in terms of technology, we are looking for PBS, pencil beam scanning. This is the delivery of choice today. I suppose all systems that are available today are really all pencil beam scanning. Now, in terms of our technical specs, you can see that for irradiation nozzle, it's quite a lot of parts, but those are important for us, and it's probably the same for most systems. And you can see that it's pretty much like a LINAC. It's just that there are scanning magnets where we can actually have the pencil beam to be projected onto a 2D surface layer by layer to paint the target. And this is just an overview of our irradiation nozzle. Then in terms of profile monitor, we have a profile monitor actually back up in one of the parts in the nozzle, and you can see that when the profile monitor is out, you can actually get the different spot size. You can actually use it to broaden the beam, which makes it more robust against a moving target. And the physics of things just tells us that multiple Coulomb scattering will actually spread out the beam, and the sigma of the beam might just grow with depth from different energies as well. Now, this is one of the challenge for us, and when we are looking at treating superficial or pediatric patients, we want to reduce the spot size for lower beams especially, and we will have a lot of benefits that might go to our head and neck as well as pediatric patients. And therefore, we are looking at how we can actually have some design where we can actually reduce the spot size for low energy beams that will benefit these patients. So one of the design that we are working on with Hitachi is really to have a small field ERS with a reduced air gap, whereby we can have a smaller sigma on the spot size, delivering onto a head and neck patient, for instance. And this is in the design phase, and we hope to finalize it soon. The other one is the multi-energy extraction. As you know, in a synchrotron system, we need to decelerate the beam before we go on to the next energy. But with a multi-energy extraction, we are able to move the beam to a different energy without this deceleration process. So the MEE feature really helps us to speed up our PBS delivery on the patient. The other mode of delivery for PBS could be discrete spot scanning, which is quite standard. These are beams which come on and off whenever it moves from spot to spot. There will be a beam off, and then you beam on again when it goes to the next spot. But we are also working with Hitachi to have dose-driven continuous scanning, whereby the beam is on all the time. And as the beam moves, it doesn't need to ramp down, it just moves from spot to spot in a continuous fashion, and with that we can actually have a faster delivery. And you can see here that we can cut down the beam off time, and we can have a much better delivery on our system. So we have done some studies on this dose-driven continuous scanning, and we find that the dose distribution is as good as the DSS. And in terms of the gantry room, just want to highlight that we have 360 degrees full rotating gantry, and this will allow us a high degree of freedom to treat our patients in a non-coplanar setting. And here we have the 6 degree of freedom robotic couch, where we have designed it in such a way that you can see here at the right corner here that we have built in the medical gas power outlets and LAN ports into the couch as well. This will help us to be more efficient treating patients as well, for example, pediatric patients, as well as for patient-specific QA for physics. And it's in terms of X-ray imaging, we have got retractable X-ray imaging panels and shorter SID and imaging panel source image distance where we wanted a high quality image. And this will allow us at the same time to perform IGRT or CBCT on our patients. And so we hope that we can continue to improve on CBCT imaging for Hitachi system by designing bow tie filters with Hitachi. For the positioning system, again, it's similar to a LINAC. We can have 2D, 2D, 3D, 2D, or 3D, 3D matching. Another feature for us in our system will be motion management. We would like to do a tumor tracking, and with this, we've adopted a system in Hokkaido where they actually design a real-time tumor tracking radiotherapy system, which is running for the Linux, and we are adopting this for proton beam therapy as well. And this technology will allow us to track the tumor and deliver the pencil beam when the tumor is in the correct position. That would mean that we're going to have markers in place, and that will allow us to have more precise PBS on our moving targets. So just some closing comments. the RFP or tender process is a kind of a very complex process for us, and it took us quite a while. Technical specs need to be monitored, and we continue to improve the system with our vendor. Clinical indications and protocols need to be established and approved. For this, we have a lot of discussion with the Ministry of Health. And key areas not covered, those listed there are largely a lot of physics related or radiobiology related work that needs to carry on. We need to have good partnership with the vendor, manpower and staff training. They are important, as mentioned earlier, and equipment building interface and IT integration are also quite complex, and we must get it right, and we have to identify what are our special needs, and especially for pediatric, we are looking at nursing, the workflow, and the availability of medical gas, and so on and so forth. So with this, I just want to wish all of you in Australia a blessed Christmas and a timely COVID recovery in the new year. And thank you for your attention.
James, that's fantastic. Thank you so much. And a really fantastic presentation. What a wonderful new cancer center you're building. And it's just amazing to see that degree of technology being built. So very impressive. I think you're going to have thousands of requests for visits once you get open. So once we're able to leave Australia again, of course, at that point.
Oh, yeah. We would love to come to visit Australia as well.
Oh, thank you, James. That's really fantastic in that way. We have one question in, and it says, what is the image on the SID, that source to image distance? So,
So the source to image distance is at about 1.6 meters. This is the distance that we designed with Hitachi. Hitachi initially wanted a larger SID system distance, but we felt that that will compromise on image quality.
That's brilliant, James. Thank you so much, and best wishes with those presentations, and thank you for good wishes back. It's now my pleasure to hand over and introduce my colleague, Associate Professor Shankar Siva from the Peter MacCallum Cancer Centre. Shankar is our current Victorian Cold Batch Fellowship Fellow, and over to you, Shankar.
Hello. Okay, thank you very much, Gerry. I did really appreciate that. Really enjoyed that talk from James as well. Today we are starting this session by introducing Eunji Hwang, a fellow radiation oncologist who has pre-recorded a presentation. It's going to be quite a good one related to clinical evidence of proton therapy, what's new in 2020. Please do remember to put in some questions in the live Q&A format, because there will be 10 minutes afterwards for a presentation and question time, and Eunji will be joining us for that session. So please do post your questions as we go. Okay, over to you, Dr. Hwang.
Hi, my name is Eunji Hwang, and I've been given the talk today called Clinical Evidence for Proton Therapy, What Was New in 2020. Just to set the scene for the world stage of particle therapy and proton therapy, as of September 2020, 109 particle therapy centers are operational worldwide, the majority of which are proton beam therapy centers, and 67 in addition are under planning or construction, which of course includes the South Australian ABC Centre. There's growing momentum around the world, and as of the end of 2019, over 222,000 patients have been treated with proton beam therapy. This momentum is spurred on by its promise of attractive theoretical benefits, or to improve the therapeutic ratio. In the case of proton beam therapy, this is sparing of critical structures, particularly relevant in small enclosed spaces, and a reduction in integral dose relevant for pediatric populations in particular. There is also the potential for dose escalation and improved control and cure as a result of this in some tumor subgroups. These theoretical benefits are well supported by dosimetric studies. However, do these theoretical benefits translate into clinical results? And if so, what is the quality of clinical evidence that is out there? Conveniently, this review by myself and some other very familiar names, I'm sure, has recently been published, which asked this very question, a systematic review which aimed to update the clinical evidence base for both protons and carbon ion therapy. The last comprehensive systematic review of this kind dated back to 2012, and that's the de Rouchier article that you can see at the bottom there. This covered a period from 2006 to early 2011 and itself was an update of an earlier systematic review by Lodge et al. In 2007, which covered the period from 1980s to 2006. 3 major databases were searched by 2 independent researchers, and the evidence quality was classified according to the National Health and Medical Research Council evidence hierarchy. Studies must have reported a tumour outcome, so local control or overall survival as an example, include at least 20 patients and have a minimum of 2 years median follow-up. Toxicity outcomes were desirable but not mandatory for this review. 1,606 potentially relevant studies were identified spanning the period from 2011 to March 2019, of which 133 met inclusion criteria for this review. 2/3 of the studies related to proton beam therapy alone. Of these 88 proton beam therapy studies, nearly 90% were of level 4 strength of evidence, such as case series, the majority of which were conducted retrospectively. There were only 2 randomized control trials of level 2 evidence found eligible for inclusion. One compared proton beam therapy to transarterial chemoembolization for hepatocellular carcinoma. The other, which I'm sure many would be familiar with, was published in 2018, was novel in its randomized comparison of proton beam therapy with IMRT for 149 patients with locally advanced non-small cell lung cancer. Looking at this study a little bit more in depth, despite a significant reduction in low dose volume in the dosimetric histograms as seen on the left graph, the proton beam therapy group actually experienced a 10.5% grade 3 or more radiation pneumonitis, compared with only 6.5% in the IMRT group. There was no difference in local failure between treatment arms. Several proposed reasons have been suggested for why a reduction in radiation pneumonitis was anticipated but not demonstrated. For example, some have pointed to flaws in the method of randomization, a mismodeled biologic effect from greater uncertainty in factors included in the dose computation model, greater setup uncertainty, or incorrect choice of endpoint definitions. There was also the likelihood of a steep learning curve with proton beam-based planning, as seen in these graphs, where combined rates of local failure and radiation pneumonitis in the proton beam therapy group were 31% in the first half of patients recruited versus 13.1% in the latter half. Such issues need to be addressed in the design of future proton beam therapy studies. This complementary systematic review was also published this year by the same cross-national authors, concentrating on toxicity outcomes as a separate focus to tumour outcomes. Together, these reviews provide a comprehensive collation of the evidence relating to particle therapy outcomes in clinical practice. There were 62 articles which examined toxicity outcomes alone and were excluded from our earlier systematic review on the basis that no tumour outcomes were reported. These 62 articles were examined and 52 were ultimately included following full text review. These were then added to the 127 which reported on both tumour and toxicity outcomes included in the previous review, a total then of 179 studies for this review. Again, looking at the strength for proton beam therapy studies, this demonstrates that 3/4 of the proton beam therapy studies to be of level 4 case series evidence. You're of course welcome to read the reviews in more detail yourself, but to summarize shortly here the state of clinical evidence for proton beam therapy, most evidence remains of low quality, mostly single institution retrospective case series with a high risk of bias and probability of confounding results across the studies. Nevertheless, there is a unifying conclusion that particle therapy, at the very least, is equivalent in survival outcomes compared to photon radiotherapy controls. In saying that, most proton beam therapy studies use the same dose and fractionation as photon radiotherapy protocols, and dose escalation has not been tried as much, except for in some sarcoma subgroups. Dose escalation trials would be an important future step if toxicity profiles are shown to indeed be reduced with proton. The reviews support the potential for reduction of morbidity with particle therapy for head and neck tumors, pediatric tumors, sarcomas, gastrointestinal tumors, and ocular tumors. Specifically, the review supports the use of proton beam therapy for pediatrics, base of skull chordoma, and chondrosarcoma, spinal and paraspinal sarcoma, ocular tumors, meningiomas, and paranasal sinus tumors, which is in line with current international recommendations. But again, emphasizing that more evidence and more data is needed. And there continues to be a mounting literature in regards to proton beam therapy, with many great specific reviews and consensus papers being published frequently. A sample of some of the reviews from just this year is shown on this slide. I thought I would briefly highlight some studies published since our systematic reviews and studies reporting on comparative data as opposed to a review paper. This phase 2B trial randomly assigned patients to proton beam therapy or IMRT to a dose of 50.4 gray with concurrent chemotherapy for locally advanced esophageal cancer. Patients were stratified for histology, resectability, induction chemotherapy, and stage. The endpoints in question was the total toxicity burden, called the TTE, which was a composite score of 11 distinct adverse events over the first year following treatment, and progression-free survival. The trial ran from 2012 to 2019. Of the 145 patients randomly assigned, 107 were evaluable and 51 underwent esophagectomy. Arms were well balanced other than proton patients having a poorer performance status. At a median follow-up of 44.1 months, the posterior mean total toxicity burden was 2.3-fold higher for IMRT, and the mean post-operative complication score was 7.6-fold higher for IMRT. The mean length of post-operative hospitalization was less with proton beam therapy. And despite these toxicity reductions, there was no difference in the 3-year progression-free survival, overall survival, or quality of life. The investigators concluded that proton beam therapy reduced the risk and severity of adverse events while maintaining similar progression-free survival compared with IMRT. This is the first positive proton versus photon randomized trial, which has paved the way for additional randomized data to be forthcoming. And there has been activation of this follow-on trial, the NRG-GI006. This trial is assessing whether overall survival is improved or is non-inferior, and grade 3 or greater cardiopulmonary toxicities are improved with proton beam therapy compared to IMRT to 50.4 gray with concurrent carboplatin paclitaxel followed by surgery in eligible patients. It'll be interesting to see whether the magnitude of benefit with proton beam therapy will be even greater with the use of pencil beam delivery as opposed to the passive scattering primarily used in the phase 2B version trial. This isn't the only randomized trial underway, of course. According to clinicaltrials.gov, as of November 2020, there are 162 recruiting trials examining proton beam therapy, 56 of which are phase 2 or phase 3. As we know, meaningful results from these trials will take some time. We also know that there are recognized barriers to acquiring this level of evidence. For example, some consider the pursuit of level 1 evidence in all circumstances and particle therapy subsites to be unfeasible or even unethical in some cases. We know that tumors set to benefit most from proton beam therapy are pediatric and other rare tumors. And the reduced incidence of late toxicities such as secondary malignancies resulting from lower integral dose from particle therapy compared to photon radiotherapy may be virtually impossible to test in a randomized trial due to the relatively low absolute incidence and latency of these cancers. Then there are the challenges inherent to performing randomized controlled trials on testing new technologies. For example, when technology is rapidly evolving, such as the field of image guidance, there can be a misalignment of pace of technology leading to unbalanced comparisons. For example, IMRT with passive scattering proton beam therapy. Many people point to the fact that the introduction of IMRT and stereotactic ablative radiotherapy took place largely without randomized clinical trials. Then, of course, factors of high capital costs for setting up proton beam therapy centers and the relatively small number of facilities worldwide also contributes. What is agreed is that more clinical evidence, however, is needed in the proton beam therapy space, especially since physical and biological uncertainties of particle beams raises concerns regarding the potential for increased toxicities close to the high dose target volumes, but perhaps we need to think outside the box. The feasibility of conventional randomized trials should be evaluated for different tumor sites. As a supplement to, and while awaiting results from, appropriately powered randomized studies, alternate data collection methodologies can help to inform immediate gaps in evidence, generate clinically appropriate trial hypotheses, derive data from the real-world patient in everyday clinical practice, and provide for much longer duration of follow-up. Different jurisdictions around the world have approached the call for supplementing the paucity of evidence available differently. Consideration needs to be given to alternate methods of data collection and reporting, including registry-based clinical trials, longitudinal observational studies, and prospective databases for proton beam therapy outcomes. As curated databases and registries provide a growing volume of data regarding toxicity, tumor control, quality of life, and patient-reported outcomes, our understanding of proton beam therapy and its relevant indications will evolve. There are examples of this happening on a large scale around the world. The European Particle Therapy Network, or EPTN, is Europe's prospective data registration program for the most common tumor types treated with particle therapy. In the US, the Pediatric Proton-Photon Consortium Registry, PPCR, with a standardized approach to collect clinical, dosimetric, and radiographic and patient-reported data for patients undergoing proton beam therapy. It recently expanded to include photon-treated patients, recognizing the need for collaboration, data sharing, and consistent analysis and comparison. The EPTN is likely to join forces with the PPCR for their pediatric patients, again recognizing the value of collaboration in these rare tumor groups. And if RCTs, randomized control trials, are to be conducted, those where patients are selected using biomarkers such as hypoxia, dosimetry, or normal tissue complication probability models are considered more sensitive and appropriate. Clinical evidence from these methods of data collection are coming through, and I'm going to point out some that have been published since our systematic reviews. This study by Kahali, published this year, is the first study to compare intellectual trajectories between pediatric patients treated for medulloblastoma with proton beam therapy versus those with photon radiotherapy on comparable contemporary protocols. It was not a randomized trial, given its pediatric study focus, but one derived from high-quality, prospective database-derived data. Longitudinal intelligence data from 79 patients were examined. Groups were similar on most demographic and clinical variables, including sex, age at diagnosis, craniospinal irradiation dose, and length of median follow-up, which was 4.3 years. Adjusting for covariates, the proton beam therapy group exhibited superior long-term outcomes in global IQ, perceptual reasoning, and working memory compared with photon radiotherapy group. The photon radiotherapy group exhibited a significant decline in global IQ, working memory, and processing speed, while the proton group exhibited stable scores over time in all domains, with the exception of processing speed. The investigators concluded that this study provides the strongest evidence to date demonstrating an intellectual advantage with proton beam therapy in the treatment of pediatric medulloblastoma. Even in the context of craniospinal irradiation, patients treated with proton beam therapy exhibited stable intellectual outcomes in most domains and experienced significantly better long-term outcomes in global IQ, perceptual reasoning, and working memory compared to patients treated with photon radiotherapy. Neurocognitive sparing did not come at the expense of disease control, with both groups experiencing comparable rates of relapse. Their conclusion: in the absence of randomized data and in conjunction with the mounting evidence that proton beam therapy reduces treatment-related morbidity for children receiving craniospinal irradiation, the study further suggests that children with medulloblastoma should be treated with proton therapy over conventional radiation when feasible. The final example, this was a retrospective and non-randomized comparative effectiveness study looking at adults with non-metastatic locally advanced cancer treated with concurrent chemoradiotherapy, but included large numbers of nearly 1,500 patients. The primary endpoint was a 90-day adverse events associated with unplanned hospitalizations. Secondary endpoints included ECOG performance status decline during treatment, 90-day adverse events of at least grade 2 that limit instrumental activities of daily living, and disease-free and overall survival. Data on adverse events and survival were gathered prospectively. It showed proton beam therapy to be associated with a nearly 2/3 reduction in 90-day severe adverse events, both grade 2 and grade 3, unplanned hospitalizations, and a lower risk of performance status decline. There was no difference in disease-free or overall survival. Their conclusion was reduced adverse events associated with proton beam therapy could offer an opportunity to intensify chemoradiotherapy treatments and/or broaden inclusion criteria on clinical trials to include older, sicker patients, which may improve oncological outcomes. Prospective clinical trials of proton versus photon chemoradiotherapy are warranted to validate these results. I wanted to spend a slide or two focusing specifically on the UK example and their approach to contributing to building clinical evidence for proton beam therapy. I've just returned from a 1-year clinical research fellowship there at the Christie Proton Therapy Centre in Manchester, which is currently the UK's only operational, publicly funded NHS high-energy proton therapy centre, with the London Centre in UCLH projected to commence treating patients next year. Well before the first patient was treated at the end of 2018, preparations were underway in the UK to position themselves to systematically evaluate proton beam therapy by focusing on outcomes, utilising data from each patient treated, ensuring every patient counts. The emphasis on collecting outcomes data on every patient from the start is shown in the formulation of the Proton Outcomes Working Group in 2014, formed to examine the data collection requirements for patients receiving proton beam therapy, as well as formulate the informatics solution to accomplish this. Stakeholders from across discipline and across trusts comprise the group, including oncologists, paediatricians, statisticians, the NHS digital team, and NHS England. Together, a vision document, a nationally agreed data set and surveillance policy was devised in 2016. The data set is comprised of patient, tumour, and treatment-related factors, as well as the required outcomes data sets. As a lead-on from the work of the Proton Outcomes Working Group, the Proton Clinical Outcomes Unit was established in 2018 and now collects, manages, updates, and analyses proton outcome data, both prospectively from patients treated through the Christie service, as well as retrospectively from UK patients referred and treated overseas through their Proton Overseas program, which has been running since 2008. Over 1,600 patients have been treated via this overseas program to date. The Christie electronic patient record system was repurposed to provide a platform for outcome tracking using electronic forms or e-forms populated with an appropriate data set. Data is collected at all important time points along the patient pathway, from referral to MDT discussion, treatment reviews, and follow-up, including patient-reported outcomes. DICOM or dosimetric data is also collected with the aim of correlating with outcomes data to support radiation dose modelling. The design of data capture has tried to be as user-friendly as possible, as we all know clinicians can be very time poor. eForms use a data tree approach using conditional logic, where further questions depend on previous answers and are sensitive to tumor site and time point in the patient's pathway. Relevant data is automatically populated across to other forms as appropriate, saving time and ensuring data consistency. At each point of care, clinicians are prompted to ask individually tailored questions, improving the quality and completeness of clinical assessments, thus supporting clinical care as data is collected simultaneously. The data is also there to help clinicians and the users. Input data will generate individualized output, such as consultation letters, treatment summaries, or surveillance plans, based on organs at risk, age, sex, and place on the follow-up pathway. Relapses or significant toxicities can be flagged as they occur, allowing timely care for patients and real-time feedback. For well-defined patient populations, outcomes data allows an accelerated evaluation of the efficacy and toxicity of proton beam therapy, providing a platform to generate hypotheses for and inform design of future clinical trials. Which brings me to the final feature of the UK approach to data collection and evidence generation, the unique relationship of the PCOU with clinical trials and evaluative commissioning. Of the anticipated 1,500 patients expected to be treated annually at full capacity within the NHS, half the patients will fulfill routine commissioned eligibility criteria, and the other half are expected to be analysed and evaluated as part of clinical trials or evaluative commissioning. With this top group here, called routinely commissioned, many of these at present are made up from the over 1,600 patients referred and treated overseas, mainly Germany or the US, via the Proton Overseas program. Outcomes data collection for this cohort presents an opportunity with these large numbers to evaluate tumour and toxicity outcomes in proton beam therapy with a long follow-up, and is in fact one of the projects I am still involved with through the Christie Group. In regards to clinical trials, as the PCOU holds the sole responsibility for data relating to proton beam therapy outcomes, the data collected by the clinical trials unit will be sent anonymized to the PCOU for the duration of the trial. This ensures that no proton beam therapy patient data is lost, that there is no doubling up of data collection. So during setup of clinical trials, there needs to be prior a data sharing agreement and data set alignment to be arranged. The Torpedo trial is already underway, a phase 3 randomized trial comparing toxicities between IMRT and intensity modulated proton beam therapy at the Christie for oropharyngeal cancer. The NHS Evaluative Commissioning Program, the last group, enables a limited number of patients currently not funded by the NHS to access treatment for indications that show significant promise of benefit from PBT in the future. These patients are closely monitored, and clinical and patient experience data collected by the PCOU is sent to the Evaluative Commissioning Program for formal evaluation. Adult nasopharyngeal cancers are the first indication to be tested by evaluative commissioning at the Christie. To finish off, some conclusions and some thoughts for future direction. The paucity of high-quality evidence has led many jurisdictions to develop empiric indications lists for proton beam therapy as a start, and there are some commonalities between these lists worldwide. Randomized trials of proton beam therapy are needed for relevant indications and patient subgroups to investigate whether modeled benefits translate to clear clinical benefit for patient outcomes and their cost effectiveness. Early evidence of this is coming through, such as the esophageal cancer study that I presented. Evidence could be supplemented also by other means, such as detailed database-derived outcomes information. Proton beam therapy studies should be integrated into large international clinical research networks, including prospective databases. In turn, indications will change and evolve as facilities treating with proton beam therapy better understand the clinical translation of proton beam therapy's dosimetric properties. New proton beam therapy centres, such as the Christie Proton Beam Therapy Centre in the UK, exemplify the model of embedding clinical operations within a network of research and clinical trial units, supported by funding bodies that will allow for properly conducted trials and radiotherapy quality assurance. Developing the necessary evidence base for proton beam therapy will be facilitated and strengthened when conducted within international and national networks through symposiums just like this. Thank you for your time.
Wow, Eunji, that's a really nice presentation. I'm glad that you can join us on the stage now. There's a couple of questions actually from the audience. I'm going to read a couple of these. One from Julie McCrossan. The reduction of morbidity and toxicities, you've made the case for that, and particularly could be useful in head and neck cancer patients. The question is, do you have a high-level summary of what the evidence is, and do you think we're planning to treat head and neck patients, say, in the Bragg Centre or other centres in Australia?
Yeah, so thank you for the question, Julie. So yeah, you're right. With head and neck cancers, I think the main rationale is for a reduction in toxicities. Of the evidence summarised for head and neck cancers in particular, as seen in the reviews, most of the comparative evidence, of which there was only a little bit, but of the comparative evidence, it looked mainly at oropharyngeal cancers, which showed that with proton beam therapy, there was the potential for a reduction in osteoradionecrosis rates, as well as the need for gastrostomies and weight loss. They were sort of the three parameters that came up in two of the studies looking at comparative data. Aside from reduced toxicities in the head and neck space, there is also interest in dose escalation and improving local control for cancers like adenoid cystic carcinoma, as well as mucosal melanomas, where the thought is that some higher doses could help with tumour control. In regards to whether or not we're planning to treat head and neck cancers in Bragg, I'm not sure that I'm the best person to answer that, but I do know with my experience at the Christie, their indications for head and neck cancer patients for protons was anyone sort of up to 25 years with a good, relatively good prognosis would get treatment if they had head and neck cancers if they were up to 25. Anyone above 25, for them, it was really to do with the torpedo trial that they were running. So if they were eligible for that, they would get proton therapy if they were randomized to that arm. Otherwise, it wasn't for adults as yet on their main indications criteria. And I guess that's something that as a national group and for the Bragg Centre would have to consider about, what our indications list looks like and what head and neck specific indications would be.
Thanks, Eunji. That's a very considered and detailed response. We've got a question from Thomas Cron here as well. Is there any evidence for comparing pencil beam and scatter proton delivery?
So a lot of my focus was, as you know, on the clinical evidence. So in terms of dosimetric studies, I know that there's a wealth of information out there, particularly comparing passive scattering with pencil beam, at least in terms of that clinical translation. I know that evidence for that is probably very limited. I think on a dosimetric basis, the thought would be that with pencil beam, much like sort of IMRT is to 3D conformal, that there's an advantage in terms of conformality. Other than that, I don't know that I'm probably the best sort of physics-minded person to answer that one.
No worries. Let you off the hook there. I got a question for you in terms of just the way you presented the case for the current state of play for the evidence and the need for more robust clinical evidence, but the challenges of doing technology type trials. You framed that question quite well, and you're showing the Christie type of approach to build evidence here, but what do you think the friction point is to be able to implement construction of these centres in a more rapid pace? Is it purely a cost thing, or will it be certain types of evidence? Are registries enough?
Yeah, I think, as you say, it's sort of, it's almost like simultaneously these things need to happen, that whilst centres are being built, people have to rationalise how those centres are being built and the resources being put into that. when others will argue that there's, again, at this stage, in terms of level 1 evidence, that's lacking. But I think that a combined approach on the basis of knowing first principles and the magnitude of benefit that we could gain from protons and particle therapy can't be dismissed. So I think they need to happen sort of simultaneously, and therefore thinking outside the box about these complementary methods of data collection, such as data registries, which I know Australia is already involved with, as well as collecting every patient that comes through from the start. We have an opportunity, knowing that we have the first patient that we'll treat, and collecting all the data we can from them, whether that be all their demographic data, but also their dosimetric data. That has to be of some use that we can then mine and use for our, for furthering our case into the future and helping patients.
Fantastic. All right. Well, thank you very much for your speech today, and also the Q&A session. It's been really informative. For the audience, we're going to head into our main break for this afternoon. During this time, we do encourage you to explore the platform, namely the Exhibition Centre, and find out a little bit more about Peter Mac and our work. If you want, you can also create chat rooms to connect with one another in the Sessions tab. But most importantly, go have a stretch. We'll catch you in approximately half an hour. We're bang on time, so I'll be returning, at 4:05 p.m, so 4:05, 5 past the hour, with another set of dynamic presentations, kicking off with the guest speaker, Susie Shiggy. See you all then. Thank you.